Alrighty, 8th grade, we're back for the last section in chapter 5. Okay, so if we decide to pull out our vocab sheet here, which is right here. Now, we skipped the vocab from 5.7, so we're going to go down to 5.8 here. A scale drawing is going to be a two-dimensional drawing of an object that is proportional to the original object. So when we did the scale drawing project at the beginning of the chapter, when you drew your picture of your partner, that was your scale drawing. It was proportional to the original drawing. It was a similar figure, but it wasn't the same. Scale is the next one. That gives us the ratio of the dimensions in the drawing to the real dimension of the original object. And the simple version of that one just simply means that it's how much you either enlarge the figure or you decrease the size of the figure. Okay, a scale model then is a three-dimensional drawing. Meaning, like, a scale model is an action figure. We are going to focus on scale drawings. We're going to make you do three-dimensional stuff in here. Okay. A reduction is going to be a scale drawing that is smaller than the real object, and an enlargement is a scale drawing that is larger than the real object. So a reduction means that you're making the original object smaller, and an enlargement means you're making the original object bigger. Okay? So let's start looking at a few examples here. This shouldn't take too terribly long. So when we're dealing with scales, they'll always be drawn in one of these three options here, either this one, or this one, but they all mean the same thing. It means the scale is first. Maybe I have this backwards. Yeah, the scale is first and the original is second, meaning that one measurement on the scale is equal to 20 measurements in the real world. So this is going to be a reduction. Here, 1 centimeter on the drawing is equal to 1 meter in the original. So this is a reduction. And here, 1/4 of an inch is equal to 1 foot on the original picture. This is also a reduction. But this is what I want you to remember. Scale over real. Meaning that when you take this information here, you will always write it as a fraction. So 1 to 20, you would write it like that. 1 centimeter to 1 meter, you would write like that. And 1/4 inch to 1 foot is going to be tricky, but you would change that to a decimal and put it over 1 foot. You can't, because you don't want fractions inside of fractions. Okay? So now we can look at some examples. So the length of an object on a scale model is 8 centimeters, while its real length is 48 meters. What is the scale? Well, we remember from our last slide that we always want scale over real. So that means we're going to do 8 centimeters over 48 meters. Okay? Well, we are not going to simply divide because that would give us a decimal. We want to keep it as a fraction. So we could divide by 2 to get 4 over 24. Could divide by 2 again to get 2 over 12. Can divide by 2 again to get 1 over 6. And let's put the label back on there, 1 centimeter over 6 meters. And that is our scale. Now we just have to draw it like our other ones. 1 centimeter is equal to 6 meters of the original. This is the scale. And this is the original. All right, if you have questions, please ask me. Okay, I'm here to help. Let's get some actual story problems in. Here is a map that I got off Google Maps from Sioux Falls to Brookings. On the actual map itself, it was 1.7, that's hard to tell, but 1.75 inches. And the scale model that I got off Google Maps said that 1 inch on the map is equal to 30 miles in real life. So I want to find out what is the real distance. How far is it from Brookings to Sioux Falls? So what I can do is I can take our fraction that we were using, which is scale over real, and I can simply do what they have here. 1 inch over 30 miles is equal to 1.75 inches over x, because that's what we're trying to find out, the real distance. Now I can ignore all of these labels because I want miles down here. So I just have to simply cross multiply, which means I have to do 30 times 1.75. And since it's a 1 there on the x, I actually don't have to do anything else. So 30 times 1.75 is equal to 52.5 miles. Now, you may be looking for a shortcut already, but I'll tell you, it's always best to do the whole cross multiplication method, even if you only had to do 30 times 1.75. Okay, because if one of these were flipped, it would have been a much more difficult problem. All right. So here is a scale model of a house, and we know that the real house has 36 feet. And the scale is going to be 3 inches in the model to 2 inches in real life, because it'll always be scale to real. Okay? Therefore, we want to know the length, or the height, I'm sorry, of the model house. So if we do our fractions again, that's scale over real. And we do our scale of 3 inches to 2 feet. And we know that the scale now is the x, and the model, or the real house itself, is 36 feet. Now notice that feet are always on the bottom here, and this will be inches on top. Now we just have to do cross multiplication, which means we have to do 36 times 3, which is 108. And that's going to be equal to 2 times x. Now we have to divide by 2. And divide by 2, and this is going to be 54 inches, because our label had to be in inches because of our scale. So this right here means that our scale model is going to be 54 inches tall. All right? Last one here, I want you to try this on your own. You decide that you want to enlarge your favorite picture from your phone. If the picture was 3 inches tall and 2 inches wide on your phone, what is its new height if the scale factor at Kinko's is 1 inch to 5 feet, or 1 inch to 5 inches? Okay, so we're back. So for this one, we know that the scale factor is going to be 1 inches to 5 inches. Therefore, it's going to be scale over real again. So we care about this number here. The height of it was 3 inches. And we're looking for the new height, so that's x, and we're going to set that equal to 1 inch over 5 inches. Now we just have to cross multiply, and it turns out to be an easy one. The answer is 15 inches. Alrighty, that's it. If you have questions, ask me. So our assignments here, this is number 1. This is going to be 11 problems, so you have to get 9 right. And this one down here is 11 problems, so you have to get 9 right. Alrighty, good luck. The Super Bowl is about to come on. I have the Patriots winning by 7. So we'll see if I'm right.